The purpose of this video is to demonstrate how to find the area of a parallelogram. Now, we can start out with just talking about a few basic definitions. The first one is, what is a parallelogram? Well, a parallelogram is a quadrilateral with two pairs of parallel sides. Rectangles and rhombi are examples of parallelograms. Now, here I have some pictures of parallelograms. Here we have a rectangle. By definition, a rectangle has two sets of parallel lines that are opposite of each other, and it has four right angles. Now, whenever we want to show right angles, we can make a little mark like that, and we know that it is 90 degrees. Now, this is a special type of rectangle. It's a square. The difference between a square and other types of rectangles are all four sides of a square are the same length. And here's an example of a rhombus. Now, a rhombus is a lot like a square in that the lengths are all the same. Like if this was 5 centimeters and this was 5 centimeters and this was 5 centimeters and that was 5 centimeters, this would be a rhombus. And the angles that are opposite of each other are congruent. And those two angles there would be congruent. Now, this is a parallelogram that we're used to seeing traditionally. It looks a lot like a rhombus, except for where the rhombus has a distinctive diamond shape to it, and all sides are congruent. Not all four sides are congruent on this parallelogram. This side is congruent and parallel to this side, and this side is congruent and parallel to this side. This angle is the same as its opposite here, and this angle is the same as this angle here. So these are examples of parallelograms. Now, just to kind of speed things along, anytime that I have a what looks like a right angle, let's assume that it is a right angle, because I'm not going to be able to go through and draw those little squares and keep this video under 15 minutes. So just assume or consider it a given whenever you have what appears to be 90 degree angles, they are 90 degree angles. Alright, now here we have a formula for finding the area of any parallelogram. Area equals base times height. Now, anytime you have two variables that are side by side, that means that you are going to multiply the numbers that they represent. Now, A stands for area, B stands for base or length, and H is height or width. Now, you might be used to seeing formulas for some parallelograms like rectangles. You might be used to seeing them perhaps written as area equals length times width. I like to say area equals base times height because, well, it means the same thing. I mean, the length is going to be the longer baseline, and base is simply the line that's perpendicular to the height. And in this case, here we'd have a perpendicular line which would represent height, or it could represent width. The reason I like to use the formula area equals base times height as opposed to area equals length times width is you can use those same variables in so many formulas. You can use them when you're trying to come up with a formula for triangles or trapezoids. So I like to use that area equals base times height, but you probably will often find the formula to find the area of a rectangle as area equals length times width. When you sometimes encounter a square, you may see the formula as area equals side times side. This being an S and this being an S. And anytime you have a variable attached to another variable with parentheses, that means you multiply. Since this side is congruent to that side, and that side is congruent to the others, and this is congruent, and I know it kind of left a little tail there, but since they're all congruent, you can just say base and width. It doesn't really matter. And or base and height, and you can still use that same formula. You don't have to remember a ton of formulas, but you are likely to see area equals length times width when you're working with parallelograms or rectangles. You're likely to see area equals side times side when you're working with squares, but base times height means the same thing. Now, I am a teacher who is more concerned about, can my student get the right answer any way that is best and easiest for them. I'm not too concerned that they memorize things that might mess them up, because sometimes if they forget the formula, then they cannot computate the problem, and so they want to use area equals base times height. I'm all for it. That's the one we'll be using in this video and in other videos that go along with this series. Now, here we have an example of a rectangle, and you can imagine that all of the corners are 90 degrees. Let's say this particular rectangle, we can say that it is maybe 8 inches high and perhaps 12 inches long. And the formula, once again, area equals base times height. Area equals, well, the base is going to be 12 inches, and the height is going to be 8 inches. So 12 times 8 will give us 96 inches square. Now, it's important that you keep your unit of measure consistent. If it's inches here and inches here, it should be inches here. And it's also important that you put that exponent 2 to show that it's squared, because essentially what we have done is we could actually divide this figure that I have drawn, we could actually divide it into 96 individual squares. And just to kind of prove that point, I'll try to draw some here and let you see how we could do it. Let's go ahead and see if we can't get this into 8 equal pieces. Okay, so here I have 2. Okay, I got that piece there. Okay, and now these are not going to be exactly, because I'm more or less freehanding these. Alright, so we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8. And if I were to come down here and make this into 12, well, let me go ahead and get this side taken care of. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, if we were to actually count all of these little units that I have inside here now, you would see that there are 96 of them. So it's like there's 96 little 1 inch by 1 inch squares in here. So that's why we always say that the unit of measure is squared when we're finding the area of a parallelogram. All right, let me go ahead and clear my board. Okay, let's go on to this one. This is an example of a square, and I could just say that this is 4 feet, and this is 4 feet, 4 feet, 4 feet. And we can assume, of course, all corners are 90 degrees because that's a given. Area equals base times height. Area equals, well, 4 feet times 4 feet. And that gives us 16 feet squared. And once again, our unit measure is square. And I'd kind of like to clean that up just a little bit there. All right, we'll go ahead and do a couple more examples of finding the areas of parallelograms. All right, here we have a traditional looking parallelogram. Notice how we have this line from here to here. We go from this axis we go from this axis and then we come straight down, and then this makes a 90-degree angle. This is what our height is going to be. Now here's a side length, and this side length could be 10 meters, and then of course this one would be 10 meters. This one here, we could say that that's 25 meters. We could say this is 25 meters, and this here we can just assume maybe it's 8 meters. Now when we use our formula, area equals base times height, we want the side or the length or the base that is perpendicular to the height. This line here represents our height, so the line that's perpendicular to it is this one here. This is the one that we want with it. So area equals 25 times, and our height is 8. We want to use that 8. Even though the side length is 10, that's not going to give us a good indication of true area. We want to use the height. So we don't even have to pay attention to this 10 or this 10 even, unless we were trying to find the perimeter, which is where you simply add all the lengths together of all the sides. So 25 times 8, that's going to give us 200 meters square. Now I want to point something out why we can use base times height with a parallelogram that looks like this. It does not really look a whole lot like a rectangle other than the fact that you have this line parallel to this one. But this little wedge here that we carved out when we created this line to show height, if we could cut this out and bring it over here, it would form a perfect rectangle. So that's why the formula base times height will work. Okay, let's go ahead and we'll do one more. And this next one, unless I'm mistaken, is going to be a rhombus. Now, to be a rhombus, you have to have all the sides the same length. We can make this one, for instance, how about 20 miles? Maybe there's a county out there somewhere that's shaped like this. 20 miles, 20 miles, 20 miles. Now I'd ask you, do we have enough information in order to figure out the area of this rhombus? And the answer is no, because we don't know what the height is. Now when I created this line, I meant for it to go in this axis, but for some reason it just would not work for me. But consider it starts here and goes straight down. Even though we know that the base is 20, the height is what we have to figure out now. And let's just assume the height, since this is not really that much of a slope. Let's say it's about 18 miles. Better go back and put that I, otherwise we'll think those are meters. Now 20 times 18 is going to give us 360 miles squared. Okay, so that's how you can find the area of a parallelogram. Area equals base times height. Not necessarily base times side, base times height. I hope that this video has been helpful to you. Thank you for watching.